Okay, let's unpack this. Welcome to the Deep Dive, the show where we take a monumental, centuries-old question. Is there life out there? And turn it completely on its head.
Today, we're undertaking what is really the ultimate exercise in remote sensing.
It's a huge one.
It is. We are conducting a deep dive into the constraints of finding life, but we are flipping the telescope around. Our sources, specifically the foundational work laid out by the Russian astrophysicist Yosef Shklovsky, force us to ask a really fascinating question.
Which is?
If intelligent astronomers were living on Mars right now, looking at Earth, could they gather enough proof to definitively, beyond a reasonable doubt, conclude that intelligent life exists here?
That's our mission.
Right.
And it forces us to view our own planet as an exoplanet, which is a wild thought. We have to analyze our own biosignatures and technosignatures impartially.
Right, and to do that, you have to dive into the necessary physical conditions for life, the crushing limitations of observational science, and then finally, the few unambiguous fingerprints that we actually broadcast into the cosmos.
Both biological and technological.
Exactly. And it's important to remember that historically, planets like Venus and Mars, well, they weren't always seen as the dry alien worlds we know today.
No, they were seen as Earth-like, weren't they?
Very much so. They were viewed as comparable solid, non-luminous bodies with atmospheres. And critically, they all formed from the same initial gas dust environment as Earth.
So the starting ingredients were the same.
The starting ingredients were there. This shared origin suggests that the physical conditions for the initial arising of living matter, chemically speaking, could have been similar across all three worlds. That's the potential starting point for our hypothetical Martian scientist.
Okay, but before anyone can start searching for, I don't know, Martian channels or Earth infrastructure, we need a functional definition.
Yeah.
What is the fundamental quality the Martians are actually looking for?
We are looking for something very specific and quite abstract. Life, according to our sources, is defined as a complex molecular aggregate.
Okay, so a complex structure.
A complex structure that is capable of printing similar systems, the mechanism we call reproduction, and, crucially, is capable of undergoing mutations.
So it's a triad: complexity, replication, and evolution.
That triad is the hallmark. That is exactly what we are hunting for.
All right, so let's start with the basics. Life is complex, but it relies on really a handful of relatively simple ingredients. If we zoom in on the chemistry, what are the absolute cornerstones necessary for that complex, self-replicating molecular aggregate to even form?
The list is, well, it's pretty much universally recognized by astrophysicists. You have hydrogen, oxygen, nitrogen, and the undisputed king of biological complexity,
Carbon.
carbon. It is the essential atom that allows the entire system to work.
Why is carbon so special, though?
Yep.
I mean, it's abundant, yes, but so are other elements. What is the specific chemical property that makes it the winner of this biological lottery?
Well, it comes down to something we call tetravalence. Carbon has 4 valence bonds. That means it can hook up with 4 other atoms at the same time. But what's truly revolutionary, what sets it apart, is its ability to easily form multiple bonds, single, double, or even triple bonds, with hydrogen, oxygen, and especially with itself.
And what does that versatility allow it to do?
It allows for an architectural complexity that really no other element can match. Carbon can form these incredibly long molecular chains, almost infinite in length, theoretically, with rich and highly varied side branches shooting off in 3 dimensions.
So you're not just getting a simple line, you're getting a whole structure.
Exactly. Think of the complex, convoluted shapes of protein molecules. This level of complexity and variety is essential for biological function, but it is doubly essential for what our sources call the exceptional informativeness required by DNA and RNA.
To store and transmit the genetic code.
Precisely. Life is, at its core, information coded in chemistry, and carbon is simply the best medium for writing that code.
I see. So it's not just about forming chains. It's about forming chains with enough functional variety to carry information and, execute tasks.
That's it. It's the difference between a single straight road and a massive interconnected superhighway system. The biological superhighway needs countless on-ramps and off-ramps, and carbon provides that flexibility.
This brings us to the perennial sci-fi contender, silicon.
Ah, yes. Good old silicon.
Silicon is incredibly abundant. Our research notes it is only about 5 or 6 times less common than carbon in the cosmos. So if it's so common, why is it so often dismissed as a potential foundation for complex life?
Well, silicon is often proposed as a substitute because, like carbon, it is tetravalent. It has those four bonds.
Right.
However, it fails spectacularly on the very issue we just discussed, chemical versatility, especially under, standard planetary conditions.
How so? What's the problem?
While silicon can form compounds, those compounds just can't provide the required rich assortment of side branches in complex molecular chains that carbon so easily allows. Silicon compounds, they tend to be less stable, or they require far more extreme temperatures to achieve any real complexity.
Can you give me an example?
Sure. The equivalent of carbon dioxide, which for us is a gas essential for respiration and photosynthesis, while the silicon equivalent is silicon dioxide.
Which is sand.
It's sand, a solid. That severely limits the variety and the chemical dynamism necessary for the rapid, information-rich reactions that define metabolism and biological function. That lack of variety limits the complexity needed for life to get past the most basic inert stage.
Okay, so we've got our building blocks, the carbon core. Now we need the workspace. Our sources are very clear that life requires a large quantity of liquid medium on the surface. We often think of this liquid as just a solvent, a medium for reactions.
Yeah.
But what are the two non-negotiable roles that liquid plays in the birth of life?
The first, as you mentioned, is the solvent role. It's absolutely crucial. It dissolves organic compounds, creating the necessary concentration and mobility for complex molecular aggregates to synthesize and interact. It facilitates the creation of that primordial soup.
And the second role is maybe less obvious, but it's absolutely vital for survival in the harsh early environment of a planet.
That is the protection role. In the early history of a planet, before a robust atmosphere has formed, or maybe before the atmosphere has evolved, to include something like an ozone lethal ultraviolet rays from the local star penetrate the atmosphere freely.
And they would just sterilize the surface.
Completely. A large liquid medium, specifically water, shields those primitive organisms from those lethal rays, allowing them to evolve safely beneath the surface or under the protection of a deep ocean.
When we look at potential liquids that fulfill both of those roles, the list of candidates is extremely limited, isn't it?
It narrows down very quickly to just two possibilities: water or liquid ammonia.
And water is the clear favorite.
Water is universally favored, yeah. It's due to its chemical properties and the temperature range it operates in. Liquid ammonia, while theoretically possible, imposes a major restriction. It requires a comparatively low planetary surface temperature to maintain its liquid state.
So it pushes the habitable zone, the Goldilocks zone, significantly farther out from the star.
Right. Much colder, much darker.
That brings us to the planetary engineering constraints then. Mass and temperature. If the temperature is too high, the whole system just fails to sustain the liquid water medium.
Exactly. If the surface temperature exceeds 100 degrees Celsius and the atmospheric pressure isn't high enough to counteract the boiling point, well, a water envelope simply cannot form. Liquid water just vaporizes, and you lose your medium and your shield. Game over.
Okay, let's apply this filter to our own solar system, starting with the planet closest to the sun. What does this tell us about Mercury?
Mercury's immediately eliminated. It's totally unfavorable. It has a very high temperature, being so close to the sun, but more critically, its mass is too small.
It can't hold on to an atmosphere.
It lacks the gravitational pull to retain its initial complement of light gases, especially hydrogen, which is absolutely necessary to form a persistent, water-rich envelope. And observations from Mariner 10 confirm this. Its surface is geologically scarred and dry, remarkably resembling the Moon.
But the planets we are interested in, Venus and Mars, they fell within the potential zone, at least for a while.
They did. Our sources confirm that during the formation of both Venus and Mars, the physical conditions could have been favorable for liquid water. They had enough mass and were initially cool enough.
So the possibility existed.
The possibility existed for life to arise on both worlds simultaneously with Earth. But of course, possibility and actuality are very different things. To determine if Earth actually harbored life, our Martians must now rely on observation.
All right, so the Martian astronomers, let's call them the Noachian Observatory team. They have their instruments pointed at Earth. They know the potential was there, but what can they actually see? What does Earth even look like from their perspective?
Earth would be one of the most brilliant objects in their sky. Maybe slightly dimmer than Venus appears to us, but undeniably bright. And crucially, they would observe Earth in phases, just as we see Venus or the Moon changing shape throughout its orbital cycle.
So viewing conditions are actually pretty good.
They're better than viewing Venus from Earth, because Earth is farther out from the sun's direct glare in their sky.
So the technical challenge isn't brightness then, it's resolution. We are dealing with vast astronomical distances. What is the fundamental, crushing physical limitation imposed by viewing Earth from Mars?
It is the resolution hurdle. And it is a hard limit imposed by the intervening space and the turbulence of Earth's own atmosphere. Our Martians would be unable to resolve any detail smaller than about 100 kilometers.
100 kilometers. That is a staggering limitation.
Yeah.
I mean, you can draw a 100-kilometer circle around almost any major city on Earth, and it would disappear completely inside that circle.
Exactly. We are talking about the entire scale of civilization cities, dams, major highways, all falling below that threshold of visibility.
Can you explain a bit more about why that limit is so hard? I mean, it's not just about the size of their telescope.
No, not at all. This limitation, it's often called atmospheric seeing, and it's made worse by the distance. As light from Earth travels through our own constantly moving air currents, the heat plumes, the water vapor, the pressure systems, the image is constantly blurred. It's what makes stars twinkle.
Right.
Well, from the distance of Mars, that slight twinkling turns into a massive, irreversible blur that sets this 100-kilometer physical limit. You just can't see through it clearly.
So what can they observe visually if everything is just blurred into these 100-kilometer patches?
They would certainly see seasonal shifts in color over very large areas. Think of the massive boreal forests in Canada and Siberia, or the major agricultural zones in the temperate areas of the Northern Hemisphere.
Okay, so the greening of the continents in the spring.
Exactly. The shift from the deep, photosynthesizing green of summer to the browns and eventual white of winter snow cover. That would be obvious and cyclical.
That seems like pretty strong evidence for some kind of dynamic process. So why isn't that undeniable proof of life, let alone intelligent life?
Because of the ambiguity hurdle. A rigorous Martian theorist, intent on eliminating non-biological explanations first, could easily devise multiple hypotheses to explain it.
Such as?
They could argue that the color changes are due to, say, cyclical chemical deposition, maybe changing atmospheric haze reacting with surface minerals, or cyclical geological processes related to temperature swings affecting vast mineral beds. They would not and should not jump to the most radical conclusion, life based solely on changing colors. The burden of proof is just too high.
What if they tracked Earth over decades?
Yeah.
They would see evidence of massive human impact, the systematic destruction of forests, for example.
Yeah.
That's not just a seasonal change.
They would notice these large systematic changes. But again, our sources caution that change itself is not undeniable proof of life. We see changes on non-living bodies all the time. Take Mars itself. The famous Lake of the Sun formation, which was first mapped by Schiaparelli, has almost entirely disappeared in the last century. It transformed from a sharp, circular spot into this elongated group of diffuse, dark patches. And that happened on a planet we currently believe is sterile.
And we've observed minor changes even on the moon, which is definitely lifeless. So variability is just a universal feature of dynamic celestial bodies, not proof of biology.
Correct. So the Martians are forced to conclude that large-scale changes are insufficient evidence.
If the global landscape is ambiguous, let's revisit the infrastructure. Can we find any edge cases that might pierce that 100-kilometer veil? What about the nightlights?
The city lights from Earth's megalopolises, the dense corridors of the U.S. East Coast, Europe, or Japan, are the best candidate, but they reside at the absolute limit of detection sensitivity. It's theoretically possible, but practically very, very difficult.
Can we walk through the specific constraints here? How dim would, say, a cluster of cities like New York actually appear?
Okay, so let's assume a 10-kilometer urban area is exceptionally bright. Let's say 10 times brighter than the light reflected by the full moon.
That's very bright.
It is. When observing the dark side of Earth, trying to spot this illumination, the Martians might see it as a fleeting star of the 16th magnitude.
The 16th magnitude is incredibly faint. That's something you need a serious professional telescope to even glimpse.
It is. And the primary problem isn't even the faintness itself, it's the noise floor. When Martians observe the dark side of Earth, which is only fully dark during its new phase, they are constantly bombarded by light scattered from the sunlit portion of Earth.
Ah, so even when they're looking at the night side, there's still a glow from the day side bleeding around the edges.
A huge glow. That scattered light is so intense it creates an overwhelming noise floor, making the detection of those dim 16th magnitude city lights extremely difficult, if not practically impossible. The signal is just drowned out by the noise.
This is just amazing. It confirms that the vast majority of our civilized existence, our buildings, our infrastructure, our lights, is effectively invisible to our closest neighbor.
And this leads us to the really detailed analysis done by Carl Sagan back in the 60s. He used U.S. weather satellite photography photos taken from nearby space, giving much, much better resolution than any Martian telescope could ever achieve.
And this helps us understand what is and isn't visible when you improve the resolution even slightly.
Exactly. It's a great test case.
So let's deep dive into Sagan's findings. What did those high-resolution nearby images actually show?
First, they showed clouds. Lots and lots of clouds. And the complex, whimsical shapes of these clouds often created these fleeting optical illusions that look like artificial structures, geometric patterns or straight lines. But these illusions would vanish upon repeated observation. They weren't real.
So even with resolution down to a few kilometers, were there any unambiguous traces of human activity in the most populated areas, like the eastern United States or southern India?
Absolutely zero. At a resolution of several kilometers, the urban areas simply blended into the background. Our structures, even our vast cities, are too structurally complex but too small relative to the global scale to stand out as clearly artificial patterns.
They just look like natural terrain.
They look like lumpy, dark gray, natural terrain, nothing special.
This is truly astonishing. I mean, we pour so much energy into building and shaping our world, yet from a modest distance, it's completely hidden.
It is hidden.
Yeah.
And Sagan's team found the visibility was so poor that out of hundreds of thousands of photos from the TIROS satellite series, which had a resolution of about 1 kilometer.
Which is 100 times better than the Martian view.
100 times better. Out of all those photos, only one single photograph clearly hinted at the presence of life and intelligence.
One photo out of hundreds of thousands. What was that needle in the cosmic haystack?
It was a photo of a piece of Canadian territory in Ontario, covered partly in snow, and the image showed a system of broad, parallel strips. These were later identified as traces of logging operations.
Logging. Why did logging, of all things, stand out when entire cities failed?
Because of geometry and contrast. The logging operation created vast, unnaturally straight, parallel lines cutting through the forest. And this was emphasized by the stark contrast of the snow.
So it's the regularity.
It's the sudden imposition of perfect geometric regularity onto natural randomness that made it visible. Natural processes rarely produce perfect, broad, geometric parallelism over such huge distances.
But even if the Martians spotted that one logging strip, they would still face the ambiguity problem, wouldn't they?
Exactly. Could they, based on a single isolated geometric anomaly, leap to the conclusion of intelligent life? Of course not. They would easily propose geological fault lines or strange, wind-blown mineral deposits to explain it. The evidence is statistically inadequate to support such a radical conclusion.
And the problem only gets more insidious as the resolution improves slightly, down to a few hundred meters. Sagan still found examples of geometric ambiguity even then.
He did. He analyzed patterns that looked like long, straight lines. In one case, the line was a highway in Tennessee, an obvious sign of intelligent infrastructure. But an identical feature on another photo, with the same width and straightness, turned out to be a natural, narrow, straight sand spit in Morocco.
So without a geological survey team on the ground, the Martians have no scientific way to distinguish the artificial line from the natural one. The very act of civilization creating geometric regularity is mimicked by natural processes.
And here's the profound irony, what our sources call the urban paradox. A major factor that makes our giant cities so invisible from space is our own smog and pollution.
The ultimate product of industrialization becomes an obscuring veil. It's tragic.
It is. The dirty, opaque atmospheres, the smog and industrial haze that hang over highly developed civilizations actually hide those achievements from cosmic view. It was reported that U.S. astronauts were sometimes unable to even observe the sprawling city of Los Angeles from nearby space because of the overlying pollution.
So the more developed we become, the more we pollute, and the more we cloak ourselves in this self-imposed observational veil.
Exactly. So unless the Martians possessed specialized reconnaissance satellites capable of resolving details down to a few meters, which is a huge assumption about their technological level, we are visually silent.
And even our ultimate technological signature, a nuclear explosion, is too fast and too rare to be reliable evidence.
And as you noted before, there's a philosophical irony. Even if they did detect a flash, they would likely not classify a barbaric experiment aimed at destroying life as a sign of intelligent reason. They'd probably classify it as a strange high-energy geological event. The visual search is, by all scientific measure, a catastrophic failure for the Martian observer.
Okay, the visual data is silent, it's confusing, or it's just plain absent. If we cannot see civilization, maybe we can hear it. Let's abandon the optics and equip our imaginary Martian observatory with the best modern radio telescopes. This is where the narrative shifts completely. Here's where it gets really interesting. Yes, the Martian radio astronomers would make a discovery that is not ambiguous at all. It's a truly shocking piece of data.
Tell me what the data shows.
Earth would be found to emit a radio flux on the meter wave band that is nearly as powerful as the quiet sun itself.
As powerful as the sun.
Nearly. And this isn't a slight discrepancy. The sheer output is monumental. Earth radiates millions of times stronger than any other terrestrial body in the solar system, including Venus or Mercury, on this specific wavelength.
Millions of times. That differential is so massive, it just screams anomaly. It cannot be ignored.
And critically, this discovery could be made using relatively modest radio telescopes. We are not talking about needing the largest dish imaginable. The signal is simply too powerful to miss. The Martians would immediately flag Earth as fundamentally different from all its planetary neighbors.
Okay, but how do they prove this anomaly is artificial? The Martians need more than just high power. They need definitive proof that rules out natural processes, like planetary magnetic fields or solar interactions. They would rely on 3 critical proofs of artificiality that emerge from detailed observation. The first is, as we've noted, the sheer detectability and overwhelming power. The second is variability.
How does the signal vary?
The radio emission depends entirely on which side of Earth is facing Mars. The Martians would detect a clear, unambiguous, periodic fluctuation that corresponds precisely to Earth's 24-hour rotational period.
They would literally see the continents turning.
Exactly. The output would drop significantly when massive, less industrialized areas like the Pacific Ocean, Africa, or Central Asia faced Mars because there are fewer transmitters facing outward.
And then it would spike.
It would skyrocket when the densely industrialized areas of Europe and North America rotated into view. A natural phenomenon, such as emission from the magnetosphere, would not exhibit such sharp, regionally specific periodicity tied to geography.
That is extremely compelling. It's a non-random signal tied directly to human geography. So what is the third and perhaps most damning piece of evidence? The temporal shift.
The temporal shift is the cosmological smoking gun. If the Martians had been tracking this phenomenon for just a few decades, say, since the 1950s, they would observe that Earth's meter wave emission was 1,000,000 times weaker just 70 years ago than it is today.
A million-fold increase in power in less than a century? That is impossible to explain through gradual geological, orbital, or solar evolution.
Precisely. Natural processes do not just turn on so dramatically and so recently in cosmological time. Analyzing these 3 facts, the massive power, the rotational periodicity, and the rapid recent emergence, the intelligent Martians would be forced to conclude that this powerful, rapidly changing radio emission cannot be explained by any known natural forces.
It must be artificial.
It must be. The verdict is undeniable. Intelligent life exists on Earth.
So the Technos signature is the first truly unambiguous proof of our intelligence. And the source of this radio scream is not highly focused scientific experiments or clandestine military communications. It is far more mundane and perhaps far more embarrassing.
It is the thousands upon thousands of television transmitters operating across the globe.
The ultimate proof of our civilization is broadcast entertainment.
Indeed. Our sources detail the mechanics. You have an average power per transmitter of around 20 kilowatts operating for many hours a day. And crucially, TV wavelengths, which typically fall between 1.5 and 6 meters, are ideal for broadcasting omnidirectionally. They pass freely through both Earth's and Mars's atmospheres, scattering this wasteful energy out into space for anyone to hear.
Can you put Shklovsky's quantification into context for us? He calculated Earth's brightness temperature. What does that actually mean?
It's a way of measuring radio intensity. His calculation estimated Earth's effective brightness temperature on meter waves due to TV is close to several 100 million degrees. If you were to measure Earth's radio noise as if it were a star, it would appear hundreds of times hotter than the quiet sun's natural radio brightness.
That's an incredible amount of energy.
It is. The average measured power is close to 1 watt per hertz of bandwidth, which signifies that we are emitting radio energy equivalent to the total electrical power consumption of thousands of small towns just lost into space for the sake of broadcasting.
It's an enormous cosmic attribute. This cosmic character of activity, as the sources describe it, is what makes Earth unique in the solar system.
It marks us as a developing technological civilization. This powerful radio leakage is the unavoidable byproduct of a society in its technological adolescence. A society that uses omnidirectional broadcasting to connect its populations, essentially creating a massive unintentional radio beacon.
This leads us directly to the critique raised in the sources, though. This massive energy loss is described as barbarism. It's a very strong word for technological output. What exactly does the term barbarism refer to in this cosmological context?
It is not a moral judgment, let's be clear about that. It is a judgment of efficiency. The term barbarism refers entirely to the incredible wastefulness of the process. We are broadcasting energy in all directions when 99.9 something percent of that energy is simply lost to the universe, serving no functional purpose on Earth.
And this wastefulness leads to a powerful long-term prediction about what truly advanced, mature civilizations might look like.
Absolutely. It is scientifically reasonable to assume that highly advanced civilizations will progress technologically to eliminate this waste. They will move away from omnidirectional broadcasting and channel electromagnetic waves along specific, non-scattering paths.
Like fiber optics.
Exactly. Fiber optics, extremely tightly focused directional laser communications, or massive orbital relays that capture and reuse energy, anything but just screaming into the void.
So the paradox is really striking. Our loudest signal today is a mark of our technological immaturity, and a lack of this powerful leakage from another planet might actually signal more advancement, not less.
A mature civilization is silent. If a Martian radio telescope detects nothing from a planet that looks capable of supporting life, the Martians shouldn't rule out intelligence. They should perhaps ask themselves, has that civilization become so efficient that it has chosen to become invisible in the radio spectrum?
The technological scream is powerful, but as you said, it's transient and tied to our inefficiency. If we became truly mature, we would fall silent. So beyond these fleeting signs of technology, is there a more fundamental, inescapable, and permanent sign of life? A signature so immense it transforms the planet itself.
Yes, and that signature is the biosphere. Developed life is such a powerful geochemical factor that it fundamentally transforms a planet's entire atmospheric and crustal structure over geological timescales. This method of detection is indirect, but ultimately far more certain and permanent than a radio signal could ever be.
This concept was crystallized nearly a century ago by the academician V.I. Vernadsky. What was his definition, and how did he conceptualize life as a planetary force?
Vernadsky introduced both the term and the concept. He saw that the biosphere encompasses the outer layers of the planet, including the entire hydrosphere and atmosphere, starting from a depth of up to 3 kilometers below the surface. He saw life not as something on the Earth, but as a system that is the Earth's surface.
And his conclusion about the scale of life's impact was truly mind-blowing.
It was. Vernadsky estimated that an astonishing 99% of the outer layers of the Earth's crust have been processed or reworked by the vital activity of various organisms, from bacteria to plants.
99%. So life has essentially metabolized the crust, turning rock into soil and drastically altering the atmospheric composition.
Life is the primary planetary engineer, and the most definitive, most easily observable result of this engineering is the existence of free oxygen in our atmosphere.
Oxygen is the definitive biosignature because it represents an extreme chemical disequilibrium.
That's the key. The vast majority of the massive quantities of free oxygen in Earth's atmosphere is a direct, undeniable product of plant photosynthesis. It is a biological element, not a natural geological one, in these quantities.
But couldn't trace amounts of oxygen arise naturally? Maybe through photolysis, sunlight breaking down water vapor in the upper atmosphere?
They could, and they do. Small trace amounts might be attributed to non-biological hypotheses, but the key is quantity and reactivity. Free oxygen is highly reactive. It is constantly seeking to bond with elements in the crust.
It rusts the planet.
It essentially rusts the planet. It oxidizes rocks, it reacts with atmospheric gases like methane, it wants to disappear.
Which means it shouldn't be there at all in these quantities unless something is constantly replenishing it.
Exactly. Our sources emphasize that if biological replenishment, if photosynthesis were to suddenly cease, the massive quantity of free oxygen would disappear from the atmosphere, being completely absorbed by the crust in only a few thousand years.
A few thousand years, that's nothing. That's a geological instant.
It is. Therefore, the existence of free oxygen in a planet's atmosphere is, unequivocally, undeniable proof that an active, continuous biological system has created a biosphere. It is the ultimate sign of a living planet.
So if the Martian biologists observed Earth's spectrum and detected that massive oxygen signature, their conclusion would be instantaneous and final, even if they couldn't spot a single city or hear a single TV show.
Yes. They would conclude life exists. The scale of the oxygen signature rules out all non-biological hypotheses. In fact, if Martians were really sophisticated, they would look for the coexistence of massive free oxygen and gases like methane, which are powerful reducing agents.
And why would that coexistence be the ultimate smoking gun?
Because oxygen and methane react instantly and violently in the presence of sunlight. Chemically, they should destroy each other. If you find both in large, persistent quantities in an atmosphere, it means that two separate, massive, active biological processes are generating these highly reactive gases faster than chemistry can destroy them.
One producing oxygen, the other producing methane.
Right. And that is the ultimate sign of a biological, out-of-equilibrium environment.
This speaks to the true mechanism of planetary transformation that Vernadsky identified. What drives this life imperative to chew up and rework the non-living planet?
It is driven by the sheer complexity and diversity of metabolic processes. Living organisms, particularly microorganisms like bacteria, possess the biochemical tools to decompose even highly stable compounds, like aluminosilicates and granites, over geological epochs. This process is the slow but unstoppable creation of soil itself.
So the primary tendency of life is simply to grow and consume.
It is. The core drive is to process or rework as much non-living matter as possible to use as building material for new organisms. Life is constrained only by resource availability. If it weren't, Vernadsky speculated the total mass of living matter could surpass the mass of the planet in mere days.
That is a terrifying thought. But life is, thankfully, constrained. What is the actual scale of living mass, according to his calculations?
Vernadsky estimated the total mass of living matter on Earth to be approximately 10 to the 14 to 10 to the 15 tons. While that is huge, it is millions of times smaller than Earth's total mass, and still thousands of times smaller than the mass of the Earth's crust. Life is highly effective at recycling and transforming, but it is ultimately resource limited.
This brings us back to the Mars ambiguity, then. If the absence of strong, free oxygen lines in a planet's spectrum doesn't strictly prove it's lifeless, what does it prove?
It proves the absence of a large-scale, widespread photosynthetic biosphere like Earth's. The case of Mars demonstrates that while the formation conditions might have been favorable initially, the planet did not sustain the conditions necessary for life to achieve that planetary scale transformation.
Okay.
The lack of free oxygen lines closes the door on the Earth-style biosphere, but it always leaves a tiny crack open for the possibility of very primitive non-photosynthetic life forms that haven't fundamentally altered the atmosphere.
We've completed our deep dive, looking back at ourselves through the cold, scientific eyes of a Martian observer. Let's synthesize our findings. What have we learned about the three primary methods of detection?
Well, we learned that visual observation is, frankly, unreliable. It is limited by the 100-kilometer resolution barrier, it's confused by natural ambiguity, and it's obscured by the tragic consequence of our own pollution, that urban paradox. We are visually silent.
Correct.
We learned that the technological signature, the massive radio scream, is the most direct, undeniable proof of intelligent life. But it's transient. It's specific to a certain stage of technological adolescence, and ultimately it's a sign of our massive inefficiency, our barbarism.
But the true inescapable proof lies in the chemistry of the planet itself.
Exactly. The biological signature, that planetary scale chemical disequilibrium marked by free oxygen in the scope of the biosphere, is a permanent, unavoidable fingerprint that announces life has fundamentally taken over the world.
So the takeaway for the Martian scientists and for us, as we look for life on exoplanets, is clear. Don't look primarily for structures or fleeting signals.
Look for signs that biology has successfully violated the rules of chemistry on a planetary scale. Look for compounds that should not coexist, like massive oxygen and massive methane. Look for a living planet, not just a structure.
And finally, let's return to that profound paradox of the radio scream. The one thing that makes us undeniably visible to the cosmos is a reflection of our most wasteful habit.
It forces you to ask, if we are truly successful, if we achieve resource efficiency, clean energy, and highly directional, non-scattering communications, we will effectively silence ourselves in the radio spectrum. We will disappear from the primary tool that our hypothetical Martian neighbors use to find us today.
So is becoming invisible, ceasing the cosmic scream, the ultimate silent sign of a truly mature civilization. Maybe the universe isn't filled with screaming aliens, but with highly efficient, undetectable ghosts, leaving their presence known only by the quiet breath of free oxygen in their atmosphere.
That is the question, isn't it? Is the most advanced life out there simply the quietest?